Hey, you there? Yes, you. You want to pursue maths as a career, right? But you're worried about the low income. Well, in a world defined by business and the economy, mathematics is highly valued for its importance in making informed business decisions. Simply put, people need maths and they're willing to pay for it. Today's modern world is a realm of endless opportunities, occupied by a hyper-consuming population who are more interconnected than ever before. Our developing society is defined by a rising global economy wherein businesses and investments play an integral part. To invest is to put money in something expecting it will increase in value over time, mathematically described by interest. Interest is money received based on the size of principal invested in the duration of investment. There are several forms of interest, the most basic of which is simple interest, a regular, constant payment every period as a percentage of the principal. For example, substituting $10,000 as the principal value with a 12% interest rate over 5 years gives us $16,000 earned after that 5-year time period. In contrast, compound interest is like simple interest, but the amount of money earned in one term of n is then reinvested into the principal amount. Essentially, it's applying interest on interest. Using the same values in the simple interest calculations, we can get a future value of $17,623.42. This equation can also be modified to find the past value of the investment. An investment worth $17,623.42 today would be worth $10,000 5 years ago.
Realistically though, no investment is stable enough that it would have a constant interest rate. Most investments fluctuate somewhat randomly around an average, where the average is often calculated as the mean, and the variability of the interest rate is calculated by the standard deviation. A common probability density function used to model random variations around an average is the normal distribution, better known as the infamous bell curve. It is both greatest at and symmetrical around the center, so the mean, median, and mode are all equal, and it continually declines from either side of the center.
The normal distribution is particularly good at modeling random deviations or errors from an average, as repeated random occurrences over sufficiently long periods tend to be normally distributed, so it is very effective in predicting interest rates. The size of the standard deviation is quite significant to the interest rate, as it determines the volatility of the investment and how confident someone can be in the value of the interest rate. By its definition, there is a 68% chance of the occurrence of an interest rate within one standard deviation of the mean, a 95% chance of a rate within 2 standard deviations, and a 99.7% chance within 3 standard deviations. For example, for a 12% mean with a 4% standard deviation, there is a 60% probability of the rate being between 8 and 16%, a 95% probability of being within 4 and 20%, and a 99.7% probability of being within 0 and 24%, so it is almost certain the interest rate will at least be positive.
The normal distribution represents probability density. To calculate the probability of a set range of interest rates, it needs to be integrated over that set range. Thus, given a mean interest rate and predicted standard deviation, the probability of an interest rate in the range A to B can be calculated by the definite integral of the normal distribution from A to B, where ERF represents the error function. In the case of an investment with a mean interest rate of 12% and a standard deviation of 4%, the probability that an interest rate between 10 and 15% occurs is 0.4648.
The ability to make informed business and investment decisions is crucial in a world where a successful economy is the backbone of a prospering nation and a floundering economy the bedrock of a financial crisis. The world needs a thriving economy, successful businesses, and the mathematics to support it all.